You're listening to Weather with Enthusiasm. Good evening. It is Monday, February 23rd, 2026. There's a lot of information in this one. We're going to be covering the February 2026 blizzard on the East Coast as the storm winds down, and there's just so much to talk about. Stuff about microclimates and just so many different variables that go into producing snow in a storm. And it's really much more complicated than anyone could ever realize, and also much more fascinating than anyone could ever realize. We're going to learn about the Delaware funnel effect, the Delaware River funnel effect, and which brought some of the counties about 20 miles away from Philadelphia about 8 inches of more snow. We're also going to be covering the inland trough, the inverted trough, along with the northern trough, which could sometimes be slightly different, along with trowl effect, T-R-O-W-A-L. That's something that's more commonly spoken about even in the Midwest. We have the deformation zone, but we also will be speaking about the pivot point along with thunder snow. Thunder snow is probably something that you've heard more of a discussion about. There's some other features that orographic features that probably you've never heard of before. Most people probably have never heard of it before. And we'll be talking about it today because all of these things came into play in this blizzard of 2026. First, we're just going to say Lakewood, New Jersey got 24 inches of snow. That's the National Weather Service is reporting that as of 11:50 a.m., 24 inches of snow is what's on the ground for Lakewood, New Jersey. And a lot of that, the heaviest snow fell between midnight and 5 a.m. last night, when the National Weather Service also tells us there were thunder booms. There were booms which were thunder, and there was lightning as well. The thunder sounded differently than it sounds in regular thunderstorms because of the heavy snow. Snow actually could absorb sound, so it kind of muffles the sound of the thunder. And the lightning also looks different, especially when you have all the ice crystals and the snow coming down. The lightning had a different tinge to it. And there is also a discussion about how to tell the difference between thunder and lightning and power outages, just the power outages going out. Just those things also spark up, and those things also produce booms. So there's a discussion about that, but the National Weather Service does confirm that Lakewood, New Jersey was receiving thunder snow, which also tells us why Cherry Hill, New Jersey received significantly less snow. What happens is when you have a place that's getting thunder snow, so as meteorologist Dave Murray, KTVI, he used to be the chief meteorologist in St. Louis, he now lives in Hawaii, he's explained numerous times that thunder opens the gates to heaven to snow. It opens the Shari Shemayim. The snow just comes, it acts as a cloud seed. That's really what the lightning does. And the snow just comes piling down. But places just outside actually see less snow than surrounding areas. So you have a place like Cherry Hill that, from what I saw, they may have only gotten 12 inches. That's only half of what Lakewood got. Another thing is something called, it's called frictional convergence. It's called the coastline break. As winds move from the smooth ocean to rough land, they slow and they pile up, forcing the air upward and creating a permanent band of heavier snow 5 to 10 miles inland from the beach. So this would set itself up in Lakewood instead of Belmar. But in the other article I was reading, it is something that would happen by the trees. Whatever area, whether it's the buildings or the trees, whenever that air hits, when it blows inland, and whenever it's forced up, that's where the heaviest band of snow a lot of times could occur, which could happen about 5 to 10 miles inland. That's called the frictional convergence or the coastline break. So that is a reason why a lot of the heavy snow could have occurred in Lakewood, New Jersey. Another thing is the pivot point. I'm just going to explain it. For a few crucial hours, this happens in nor'easters, where you have the storm's forward motion and the backward rotation of its snow bands get canceled out. and that causes heavy snow to stall over a specific area, which in this case, it became Lakewood, New Jersey. It also was Langhorne, Pennsylvania as well. That was included, and all the counties in between, leading to extreme snowfall accumulations. That's what we had over there. Now, regarding that happens, by the way, in just about every nor'easter. There's going to be a point where the storm's forward motion and the backward rotation of its snow bands get canceled out. But the question always is, exactly where is that going to happen? And wherever that happens, that's where you're going to have a band of snow that just sits there for just heavy snow. It's just going to stall there for a long period of time. So this happened, indicators were that it would happen right outside New Jersey, and it did happen right outside New Jersey. So now, the highest snow totals, however, were up in Rhode Island. Providence, Rhode Island saw a record breaker with this one, 32.8 inches. All of these things occurred in less than 24 hours, amazingly, along with wet snow, at least to start. The airport over there saw 36 point some inches. We'll be getting that. Rhode Island, there was no pivot point over there, and I don't know about the thunder or not. But what they had going for them was something called a trawl. It's a trough of warm air aloft. So that's what it stands for. It's a Rashi Tevos. It's TRWA, the trough of warm air aloft. It's a massive high-speed conveyor belt that reaches into the Atlantic. In this case, it reaches into the Atlantic Ocean, scooping up moisture and depositing it over the cold air in New England, in this case. And this is what was responsible for, that was the fuel for these 30-plus inch snow totals. So each area, in a certain way, each area had a different mechanism that was contributing to these very high snow totals. And in a certain way, the most interesting situation occurred in the mid-Atlantic area, in Virginia and Montgomery County, either in Virginia or Maryland. There's an area both over there where, the forecasts were calling for 3 to 6 inches because they were on the very back side of the storm. So only 3 to 6, not 12 to 18. It would have been basically 12 to 18. But with these enhanced features, you got more. You have the pivot point. You have thunder snow. You have different things like that. We also have that Delaware funnel river situation, which we'll talk about in a minute. But that 12 to 18, let's say, the 12 to 18 bullseye ends up being more like 18 to 30, or we actually, in this case, we got up to 36 inches. So up in Rhode Island because of the trawl. But we had something called it's a type of inverted trough. It's called the Norland trough. It's a narrow mesoscale trough on the northwest side of an offshore low pressure system that causes localized intense bands of heavy snow. It's often found in New England. Now, it's a big surprise. It's a more rare thing. It did occur in Connecticut a couple of weeks ago, and it could cause surprise snowstorms. This phenomenon features converging winds that force air upward, resulting in sharp, hard-to-forecast snowfall gradients, where one town may get a foot of snow while a neighboring town gets little. So there's plenty of videos online that could explain this more. And in the back of a low-pressure system, offshore low-pressure system, you could have an area where northeast winds are colliding with northwest winds, and then they collide and they create an intense area of rising air. It's kind of like a miniature storm system at the very western edge of the real storm system. So you have places in Maryland and Virginia that what happened was they were forecasting between 3 and 6 inches of snow because of this developing nor'easter. What ended up happening, however, is the nor'easter went 50 miles further east than what was originally forecasted, and therefore that combined with some warmer temperatures caused the forecast to be a bust. This means that the snow didn't really happen. You look at maybe BWI got 1.9 inches. It was mostly just on grassy surfaces. However, there's something else that happened that made it that in some areas the 3 to 6 inches actually happened, and that's because of this surprise Norland trough. It's a inverted, well, it's a type of an inverted trough, but that developed at the very edge. So some of these counties ended up getting several inches of snow, even 7 inches. I think it was Montgomery County, Maryland. We'll take a look at the counties a little bit later. But that was something that was pretty impressive. Just a real a Yad Hashem moment, really. You could imagine what people there are thinking or going through. Some people just assumed that the forecasters got it right. The forecasters got 2 things wrong, and then the forecast was right. There were 2 busts. The storm, they missed the storm, plus they missed the development of the surprise storm, but the forecast ended up being accurate anyways for these counties in Maryland and Virginia. That's one of the more interesting things I think that happened in the storm. When you go up into Pennsylvania, you have heavier snow totals that occurred in places like Philadelphia, a city that wasn't really forecasted to get so much in the beginning. That's because they're just too far west from the original storm. Now, what's interesting is, so Philadelphia was not included in any warning at all in the beginning. And then the storm went further east than what was originally forecasted. So you would think for sure Philadelphia is going to miss out. But no, all of a sudden at that point, warnings were issued for Philadelphia. So what happened over there? There's something called an inverted trough. It's something similar. It's the same idea. And due to that, it causes the snow to fall. It's like a miniature moisture conveyor belt, or some type of it's a trough that instead of dipping south, it makes a bulge northward, and it causes the snow to fall further northwest, an area of heavier snow on the western edge of the storm than what we ordinarily would have seen. So that's something that caused Philadelphia to get, to me, it's kind of like a mind-boggling thing that they got 14.2 inches, considering how far they were from the center of the storm. But they got 14.2 inches. Now, as mind-boggling as that is, then you have to realize there's parts of Philadelphia that got 22 inches. Now, how did that happen? So that happened due to the Delaware River Valley funnel effect. So the Delaware funnel is described as a meteorological phenomenon where the Delaware River Valley acts as a natural channel for moisture-rich air during a nor'easter. When a storm is offshore, it pushes moist air inland. The low-lying Delaware River Valley, extending from the bay up towards Trenton, New Jersey, funnels this air directly. This topographic channeling, combined with enhanced upward lift and trapped cold air, concentrates precipitation, leading to significantly higher snowfall rates in towns along the river like Langhorne and Morrisville compared to nearby areas just a few miles away. And you end up with places that just got a mind-boggling 22 inches. Langhorne, 22.3 inches. Morrisville is in that Langhorne area. They also received extreme snow due to this funnel effect. I'm going to read off of my notes here, and hopefully we're going to cover it all. The February 2026 North American blizzard, unofficially Winter Storm Hernando, Hernando, that's what the social media and a lot of times the Weather Channel comes up with these unofficial names for storms. It was a historic bomb cyclone that impacted the northeastern United States from February 22nd to 23rd, 2026. It set multiple all-time and daily snowfall records, caused widespread power outages due to hurricane-force wind gusts and heavy snow. The storm originated as a shortwave trough over the U.S. West Coast on February 20th, consolidating over the southeast coast to form a nor'easter. It rapidly intensified, dropping 40 millibar in 12 hours. The system began as a shortwave trough originating in the Pacific Ocean, moving ashore in California. This trough was associated with a slow-moving low-pressure system and an atmospheric river, bringing heavy precipitation to Oregon and Northern California. Now, a shortwave trough, just to define it, is an upper-level disturbance or ripple in the atmospheric flow typically found within the larger jet stream. It's essentially a pocket of colder air and lower pressure aloft that moves through the atmosphere. While not a fully developed surface storm initially, Its passage can, number one, introduce dynamics. It causes upward motion in the atmosphere, which helps air rise, cool, and condense moisture. And number two, it could trigger development as it interacts with other features like a stationary front, which we're going to see in our case, that's what happened, or a moisture source. It can lead to the formation of intensification of surface low pressure system. In the case of the winter storm Hernando, I don't know if I'm pronouncing that right, but the shortwave trough from the Pacific acted as the initial trigger, setting the stage for the massive storm that eventually formed on the East Coast. The February 20th into the 21st, the trough moved quickly across the United States. It remained largely unorganized during this cross-country transition, not yet a fully developed surface cyclone, but an upper-level disturbance. February 22nd, that was yesterday, the intensification and the East Coast impact begins. That was so late February 21st, this is Saturday night, early February 22nd, the system began to consolidate as it reached the southeastern coastline, interacting with a stationary front. Early February 22nd, a new surface low-pressure system developed off the coast of North Carolina, marking the beginning of this historic nor'easter. Its central pressure was approximately 1,009 millibars, 29.8. Not strong at all. Now, Sunday, February 22nd, in the morning, 9 a.m., rain began in southern and western New Jersey. 10 a.m., rain began in Philadelphia. 2 p.m., flurries were observed in Connecticut. Sunday, February 22nd, in the afternoon, 3 p.m., temperatures dropped and rain transitioned to snow in Philadelphia and New Jersey. The storm began to bomb out, rapidly intensify as it moved northeastward. On Sunday, February 22nd, in the evening by 7 p.m., heavy snow and gusty winds reached major New England urban centers, including Boston. Intense snow bands developed with rates of 1 to 2 inches per hour, frequently accompanied by thunder, snow, and lightning. The storm also developed an eye-like feature as it intensified. And we're going to see this phenomenal intensification in just 12 hours, because we go to February 23rd, which was the peak intensity, the blizzard conditions, and the record snowfall. So overnight, late February 22nd into early February 23rd, the storm underwent explosive intensification, dropping roughly 40 millibars in 12 hours. When I was making the podcast yesterday, it dropped only 35 millibars. But 40 millibars in 12 hours. By 10 a.m. Eastern Standard Time, Monday, February 23rd, 15 UTC, the storm reached its minimum central pressure of 965 to 966 millibars, which was 28.5 inches of mercury, achieving its peak intensity. This also marked the peak intensity for localized thunder snow, with reports from New York City, Teterboro, and Plymouth, Massachusetts, including a verified cloud-to-ground lightning strike near Plymouth. There actually was a meteorologist reporting live at the time when the lightning struck. Now, Lakewood, New Jersey went through thunder snow, as we mentioned, from midnight to 5 a.m. Blizzard conditions, which were winds over 35 miles per hour, visibility less than a quarter mile for 3 or more hours, were verified in numerous locations, including Newark and Teterboro airports in New Jersey. Most of the record-breaking snow accumulation fell within a 12 to 15-hour window, starting Sunday evening. Snowfall rates in cities like Boston and Providence reached 2 to 4 inches per hour for several consecutive hours. Monday, February 23rd in the afternoon, the snow eventually tapered off in New York City by mid-afternoon. And by this evening, the heaviest snow tapered off in Boston and Providence by 7 p.m. Eastern Time. The snow continued through tonight. It's still continuing in New England before the storm is going to be exiting to Canada. The wind gusts were reported up to 98 miles per hour in Massachusetts, and also some 90 mile per hour wind gusts in Rhode Island. Elsewhere, I saw lower amount. Verified cloud-to-ground lightning strike in New York City skyscraper, and then offshore wind turbines near Massachusetts. Meteorologists noted some reported flashes might be from power flashes, not actual lightning. And here's some of the record snowfall totals. Warwick, Rhode Island saw 36.2 inches. That's an unofficial amount. TF Green Airport is the Providence airport. This is an all-time record of 32.8 inches. This occurred in less than 24 hours. Then Central Islip, New York, 31 inches. That's an all-time record for that location. Newark, New Jersey, 27.2 inches. It's the second largest in the city history, which breaks the January 2016 record. Boston, Massachusetts, 27.1 inches. Pagoda, New Jersey, 29.5 inches. Langhorne, Pennsylvania, 22.3 inches. New York City Central Park, 19.7 inches, which makes it the 9th snowiest snowstorm. The entire system, when you include the rain and the snow, was 24 to 36 hours across the Northeast, but the most intense accumulations were 12 to 15 hours starting Sunday morning. Snowfall rates of 2 to 4 inches per hour in areas like Boston and Providence. The varied forecasts and microclimates are things that we spoke a little bit about, such as in Philadelphia, the forecast of 8 to 14 inches materialized, with 14 inches at Philadelphia Airport. Langhorne, which was 24 miles northeast, receiving 22 inches. That's due to that funnel effect from the Delaware River. The Montgomery County, Maryland, forecast of 4 to 6 inches largely resulted in 2 to 5 inches due to a sharp rain snow line. And in Virginia, the forecasts from Northern Virginia was up to 5 inches, Richmond 2 inches, and Eastern Shore 6 to 10 inches. That materialized. Here's some of the key meteorological phenomena explaining which we explained some of this. The pivot point was over New Jersey. That's where the storm stalled for several hours off the coast of New Jersey, causing heavy snow bands to hover over specific areas like Lakewood, New Jersey, and Langhorne, Pennsylvania, leading to extreme accumulations of 24 or more inches. We explained how this happens in every nor'easter, but the question is, where is it going to happen? Delaware River funnel, that is the river valley, acted as a channel concentrating moisture from the Atlantic, enhancing snowfall in communities like Langhorne and Mooresville, New Jersey. Then we have the trough of warm air aloft. That's something which impacted Massachusetts, a giant arm of the storm that drew vast amounts of moisture from the Atlantic over cold air, fueling the 30-plus inch totals in New England, particularly Rhode Island and Massachusetts. Then we have the moisture robbing. It's called localized subsidence. It's intense thunder snow cells, such as, in this case, Lakewood, New Jersey, and it draws moisture from the surrounding areas, causing lower snowfall totals in adjacent regions, like Cherry Hill, New Jersey. And then we discussed the frictional convergence, which is called the coastline break, where winds slow down from ocean to land. The wind slowdown from ocean to land creates an uplift, leading to heavier snow bands 5 to 10 miles inland from the coast. So here's the snowfall totals, which we mentioned in a previous episode, but these are the final totals. Rhode Island, Warwick, Providence area. The unofficial reports near Warwick, 36.2 inches. TF Green Airport in Warwick, this was the all-time record, 32.8 inches. For Providence, 32.8 inches. For Pagoda, New Jersey, 29.5 inches. Newark, 27.2 inches. Bayville, 25.8. Lakewood, 24 inches. Cherry Hill, 10 to 12 inches. They received less due to the moisture robbing effect from the thunder snow in Lakewood. New York, Central Islip, Long Island, 31 inches. That's an all-time record for that location. Stony Brook, 31 inches. New York City, Central Park, 19.7 inches. That's the 9th snowiest storm. Massachusetts, Wellfleet, 36 inches. Westport, 36 inches. Boston, 27.1 inches. Plymouth, 30 inches. Pennsylvania, Langhorne Borough, 22.3 inches. Philadelphia International Airport, 14.2 inches. Northeast Philadelphia, up to 16 inches. Maryland, Montgomery County, most of the county, between 2 to 5 inches. Damascus, North and West, had some higher totals. In Bethsaida, Silver Spring, southern lower amounts. Virginia, Northern Virginia, Alexandria, and Arlington, 2 to 5. I'm not sure if that was reality or a forecast. Richmond was a coating to 2 inches. And the Eastern Shore was 6 to 10 inches. I believe the forecast for Virginia ended up being correct. The Islip Airport was 29.1, but revised to 28 inches. Washington Heights, 22.1. Staten Island, 24.1. LaGuardia, 22.2. JFK Airport, 19.8. Montauk Point received an 84-mile-per-hour wind gust, which is the highest recorded in the storm. We actually saw another place which seemed to have a 98-mile-per-hour one. I don't know if that's unofficial. In New Jersey, Carstead, Bergen County, 27.9. Newark Airport, 27.1 inches. That's the confirmed final. Dakota, 29.5 inches. That's the Weather Channel. Monmouth or Strathmore, 26.5 inches. That was the 4 p.m. report. Perth Amboy, Middlesex County, 25 inches. Bayville, Ocean County, 25.8 inches. Jackson, 5 miles west, southwest of Jackson, 25.2 inches. Matawan, 24 inches. Lakewood, 24 inches. That's the National Weather Service, Mount Holly, confirmed as of 11:50 a.m. Toms River, 22 inches. Woodbridge, 21.3 inches. Burlington County, northeast Philadelphia area, 16 inches as of 9:15 a.m. And here's the detailed hourly breakdown for Lakewood, New Jersey. At 12 p.m. on Sunday, there was a rain-snow mix in 38 degrees. 2 p.m., steady snow, 1 inch, 30. The 7 p.m., heavy snow with 6.5 inches, 32 degrees. 9:16 p.m., the official report had 8 inches, 30 degrees. Midnight, extreme snow of 1 to 2 inches an hour, 11.5 inches. 3 a.m., 16 inches, 4.5 inches in 3 hours. 6 a.m., heavy snow was tapering, 20 inches, 29 degrees. 9 a.m., 22.5 inches. 11:50 a.m. was the National Weather Service Mount Holly train spotter final report of 24 inches with the peak snowfall rate 9 p.m. Sunday to 4 a.m. Monday of 2 to 3 inches an hour. The blizzard wind gusts 45 to 60 miles per hour with near zero visibility. The following came from Arrow, and I think this one is got to be accurate. 10:30 p.m. Sunday, 8 inches on the ground, which in Lakewood. 7 a.m. this morning, 16 inches, and 9 a.m., 19 inches. So some of the most notable meteorological features are the explosive cyclogenesis off the Delmarva Peninsula, the central pressure of 960 millibars, the blizzard lightning, which was captured by satellite within the cyclone spin, a rare phenomenon. The inverted trough contributed to heavier than expected Philadelphia snowfall. Snow fell even as temperatures were above 32 in Lakewood, wet and heavy snow. The storm duration appeared very compressed, rapid accumulation, then a quick exit. Thank you for listening. I wish everybody a wonderful week. Stay safe and stay up to date with the National Weather Service for your forecast and for the latest safety features regarding this storm. There's 2 more storms coming to the East Coast later this week. One of them's minor, just a couple inches, and the other one might be more significant, but could be falling as rain. Have a wonderful night. Just to go through some of the background music that we've been listening to. So at the very beginning, it was Borrow from Blue Dot Sessions. Then we heard Glass Beads, Blue Dot Sessions. We heard Waltz for Zakaria, Blue Dot Sessions. I think then we heard Glass Beads. Trans-Siberian Express from Leula Gren, Luellagren. Then we heard Dramatic Piano and Strings from Pink Zebra Audio Jungle. And right now you're hearing Shir LaMelech from, it's actually me playing the piano. Hey, what's going on here? No, that's actually Borrow from Blue Dot Sessions. That's me playing the piano at a nursing home, and from a while back, and you could hear, some forks moving and stuff like that. So, anyways, this previous episode was unique. Usually we like to do the forecast discussion, but this is something that already happened. So, I think it was also more educational. So thank you for listening. I wish everybody a wonderful night. Have a great week.